And now we can start working on our simulation. And I will go ahead and I will grab this fracture main packed node and I will Control C and move over to the right. And let's create our simulation chain over here, and I'll drop down an object merge and place this here. Okay, so this is our packed pieces. And let's maybe go ahead and grab all of these nodes and just sort of slightly move them maybe to the left. And over here we can do our separate chain that will control the simulation. So these are the packed pieces that are imported inside the .NET. And we have to remember that all of these pieces are basically just points. So if I drop down an add node from this object merge and choose this option to delete geometry but keep the points, we can see that all of these pieces are basically just points. And the way we are going to set up the simulation is we are going to create a vector for each of these points, which we will use in our simulation.NET as a force, which will drive the main movement of the pieces. So let's see what I mean by this. I will keep this add node over here and I will create another null node before our add node, and let's rename this to pieces packed. And so we will create the vector that we want to use as a force here before this pieces packed node. And this is actually the node that I want to import in our simulation. So make sure that this is before the add node, okay? We will only use this add node to preview what changes we do to the vector. But this is the object that we will import in the .NET. So let's maybe just go ahead and grab this node. So Control C, this pieces pack node, and let's go to our .NET. And let's make sure that the RBD packed object is pointing to our new node that we created. So I will paste this over here. So let's go up and let's go to our node. And before this pieces packed, I will drop down an attribute VOP and I will rename this to set dir. So we will create a vector that's called dir, which is going to be used as a force. So for now, inside this node, I will just create a parameter and I will create a tree float vector and I will plug this, so we don't need this output. We will just plug this parameter into a bind export node and we will name this dir. So this is the vector that I want to use. So if I go up, so let's visualize this vector and click on this add node and go to the information, click on the dir to create a visualizer. And so we have this dir visualizer here, and in the edit this should be set as a type marker and a style vector. Okay, and leave this at the length scale of 1 and unit length of 1 as well. Okay, so if I go to my set dir attribute VOP, here in this custom parameter that we created, if I set the y value to 1, we can see that this will be our vector. So let's leave this vector as it is for now, and let's go ahead and go inside our .NET and see how we can use this vector as a force. So back in our .NET, we will use a pop wrangle node. So let's drop down a pop wrangle and place this in our post solve node for our rigid body solver. And I will say here at force equals v at dir. And I will turn off this visualizer, and if I play this, we can see that the pieces are simply just falling. So they are only affected by the gravity, and for some reason this direction doesn't work, so this dir vector that we created. And this is because we have to go to our RBD packed objects and we will turn on this override attribute option on. So this option will specify what attributes we want to grab from outside of this DOM network from the SOP level context. So I will delete all of these and I will place my dir attribute in this list. So now each substep that the simulation is running, this RBD packed object will look at our SOP and it will look at the dir attribute and it will override it inside this DOM network. So basically this option just imports an attribute from outside of this DOM network from the SOP level context inside the DOM network. And now we can use this dir attribute inside the pop wrangle or pop VOP or anywhere inside the DOM.NET as well. So before we play our simulation, let's also scale this force by a custom channel. So after v at dir, I will type multiplies, ch, and in parentheses I will type amp. So this will be our amplitude, and let's maybe start with a value of maybe 20. So now if I play the simulation, our pieces should start flying upwards. And let's see. Okay, so we see that the smallest pieces that have the smallest mass are starting to really take off, and pretty much the larger chunks are staying where they are because the force isn't strong enough to really bring them up. So what we can do here is we can also multiply this value here, so this force, we can also multiply this by at mass. So now all of the pieces should have a consistent force applied to them, and now we should get a more reliable result from our simulation. And if I press play, we should start seeing that all of our pieces move up. Alright, and because we multiplied by our mass value and the vector has the same strength for all of the pieces, they will all now just fly straight upwards without much variation between them. But now we have a framework for how we can control the simulation with this vector, and by simply changing how this vector affects the pieces, we will be able to completely control how our pieces will act inside the simulation.